So first of all, you had to file new project. So you will start with new project and you will determine the destination. But before all of this, you had to choose the unit. So you are going to go as a US unit or as other unit.
Okay.
So I'll work with US units.
Yeah, unit, yes.
And then new project. Then you will start to determine the area that you will save your files. So I'm going to save it at Lumberton Field Study.
Okay.
And you will create your folder and like HEC-RAS models. And let's make Lumberton feet trial. This is another project.
Okay.
And you aware about how to name the folders?
Yeah.
No spaces.
Yes.
No, yeah.
Mm-hmm.
Okay. And then we will say, okay, so we will start new project. Yes.
Mm-hmm.
And then we will go to the RAS mapper here to import our digital elevation map.
Mm-hmm.
So we will get the digital elevation map from here, open, and so not open yet. You will get a train. So we'll get create new train, and it's recommended that the project spatial reference. So he said here that you had to determine your datum. Yes. So I'm going to import my projection.
Okay.
So I'm going to import it from a file. I have a file, have a datum, and I'll tell the HEC-RAS to take the datum from it.
Okay. And where can I find this projection? Do you know that?
You can no you can, first of all, you can import the digital elevation map with its projection.
Okay.
So if it's already projected, it's okay. You will skip this step.
Okay, I get
so
it.
If it is not projected and you need it to be or it's projected or not projected and you want to transform it to another projection, so you had to choose this projection from a file. So I have this file is projected to NEBD.
Okay.
And we will set open. So this is, it will be NAD 1983.
Okay.
And State Plain, North Carolina. So this is my data. Yeah. I'll say okay. And then I'm going to add the digital elevation map here. I just say add it here, and I'll go to floodplain. No, not this one. Where did I save my digital elevation maps? The Benson can, yeah, this merged one. So I'll set open this one, so it will be opened here. So I'll tell create.
Okay.
So it will take.
And if my study, because my study has been created with 4 different DEM, so can I put them
I don't think so. You had to merge them, and there's a way to merge them on ArcGIS. You will go here. Just for not ruining my files, I'm going to make a folder because I have a model here and I don't want to ruin it.
Okay.
So I'm going to say trial project folder. Trial. We'll save our files here. Okay. So if you want to merge digital elevation maps, so you will go to here at the Arc toolbox. And there's a way to do that. So I got 2 digital elevation maps.
Okay.
To merge them, you will go at data management tools and raster, and you will find a YouTube videos showing you how to use this. You will creating a new raster data set. It will be empty, and HEC-RAS, yes, create raster data set. And when you create this empty one, you are going to do a mosaic, like merging this using mosaic. So but just 4 files and he will merge them.
Okay, I got it. So at the first step, we just need to define that. And kind of empty.
Yes, like
create a space, and then we will
assign the 4. Yeah.
Okay.
From here, from raster, you will do that.
Okay, I got it.
Okay, let's go back here and let's close this because, all right, so I'll say from verse new project, and we will go to Lumberton field study and trial. I just HEC-RAS. Oh, I just created a file.
Maybe this is another drive. No?
I just Lumberton. It's a trial HEC-RAS. Yeah, here, that one.
Okay.
I'll open it, and I'm going to name one as Lumberton trial. And save all our file here. It's okay. And we will go to the RAS mappers and the trains, create new train. Yes, I want to. And here is the folder that you will pick. The projection. And then here is my digital elevation maps.
Yes.
It will be here. It's the merged one.
Okay.
Benson County merged digital elevation map. I just make sure it's for Benson County merged. Alright. So okay, open it. And I'm going to say create. So it will take like several minutes to reading this file.
Okay.
And after creating our map, so we will create a 2D floodplain area.
Okay.
So I have a big map. I need to pick the area that I'm going to work on.
Yes.
Like the area that got the flood.
Okay.
So this area it will be a 2D finite element mesh.
Okay.
Some water goes inside it, some water come outside it.
Okay. Thank you so much.
Yeah. And after defining the 2D flood area, we had to define boundary conditions. So for the 2D flood area, you don't define boundary condition inside. All is outside.
Okay.
So you may know the discharge at some point inside, but it will not be helpful. You should know the point that outside this 2D area.
Okay. So you mean that for defining the boundary condition, we just need to select outside part of
Yeah, I'm going to show you here.
Okay.
So if my stream is like this, and like this, and goes like this.
Okay.
So my 2D flood area will be like that.
Okay.
So I had to know the flow here, and the flow here, and the flow here. So if I know the flow here, it will not be helpful.
Okay.
Because he will calculate the 2 flood here, and then he will know what is the flood here.
Okay, I got it.
So, and here we just define what is the flow at these 3 points, and we will assign that the water is flowing by gravity with its normal depths.
Okay.
So we will get the flow here.
Okay.
So we define 3 upstreams and 1 downstream.
Okay, I got it.
That's what we are going to do. And for the flow, you are going to define if it's steady or unsteady flow.
Okay.
A steady flow is for the flow that it is not changing with time. That means you have a constant flow, like a river in normal condition without any flooding. But in our case, we have floods, so the flow was normal, but it comes for a high level and then goes. So it's unsteady flow.
Yeah.
That is the difference between the steady and unsteady flow.
That's great.
Yeah, and after defining our 2D flood area and our boundary conditions, we will assign something is called hydrograph. Are you familiar with the term?
Hydrograph.
Yeah, it's discharge with time. Q with time. In case of river flooding, the river is like in a normal condition, but at the flood it goes very, very high and then drop with time.
Yeah.
So this is the hazard.
Yes.
This is the hazard discharge. So this hydrograph, you can get it from the USGS.
Okay.
So you can go.
For example, you mean for these
Yes, these points.
because
So
you need to define the Q for each
one of them.
Okay.
And this Q is not constant. It's
Okay,
changing
yes,
with time.
that's right.
So I'm going to show you example. Okay, here's GIS links flood. Yeah, here. So here, this is a station, it's called Lumber River near Mixton. So Lumber River have many stations.
Okay.
Mixton is the up one. So you can assign a date to, this is the real-time state flow in the river right now. But I don't care that. I care at the begin date of 2016.
Because there was a flooding at that time?
Yeah.
Okay.
And the month is October. And the day is, let's say it's 1. And here 10, and let's say at 12:31.
Okay.
And let's say go. Look at the graph.
Okay.
It was very high here, but just not that high as much. This one, I care from this point up to this point.
Okay.
So we can change this to be 8. Yeah. Here's our hydrograph.
Okay.
This is the discharge with the time from October 8th up to October 29th. The hazard was exactly at October 10th.
Okay.
So here was the maximum discharge. This is at Mixton. Mixton is here.
And how you know these
stations? You get them from, I can show you. Right. Let's water resources. Okay, you will go. So I did that time ago. Yes, I think it's USGS water data for the nation.
Mm-hmm.
Yes, here. You will go to map all sites with links to all available water data for individual sites. And here is the map. Yeah, so my city is here. So each one of these have a hydrograph. This is all the data available.
Okay.
So I'll go here, access data, and you will go to daily data, and then put the dates here.
Okay. Okay. I got it. Thank
So
you so much.
you got the data, all the station that some station you will have it. So I have a station here, and I got a station here and a station here and one here, but I don't have that. So what I did is just assume the flow here and check the flow here, because I have that but I don't have that.
Okay, I got it. Kind of minus.
Yeah. And there's other ways. There's a program is called HEC-RAS. This program is like make a hydrologic study. You will give, you will give him the rainfall in inches and some data about the area, and he will say what is the hydrograph will be here.
So it kind of create a hydrologic analysis.
Yes.
Hydrology
it's
analysis.
Not our work. It needs some information. I have it, but I didn't work in it.
So participation. Participation, and based on the geology.
Yeah. So
create the.
I don't have it on the slide.
The flow.
Yeah. So actually USGS gets this hydrographs using the precipitation. So they did this process for us, because they put gauges on the river, and knowing the value of the water as these gauges, so he can get the flow, the hydrograph. but there's some softwares using the precipitation flow in this area and the geology and the topography of this area and how much the water get absorbed in the soil and other stuff like this. And but it will need advanced parameters like I saw that because I tried to do that to forecast.
Yeah.
But
It is hard.
Yeah, you had to read. You had to exert some work to get it.
Okay, I got it. And an interesting difference here is HEC-RAS is using the actual data, or at least the data that you introduce.
Yes, you can like if you want to go back like so when you say on HEC-RAS a 10-year flood or 500-year flood, so 10-year means that you are going to assume that it will be a precipitation like 20-inch or 30-inch. So you can go from this point.
Okay.
I'm going to assume that I'll have a precipitation of 20-inch and then go to HEC-HMS using this precipitation to get the hydrographs and using this hydrographs in HEC-RAS to get the floodplain.
Okay.
So this is the process.
Yeah.
You can start with the precipitation, HEC-HMS, and HEC-RAS.
Okay.
Now I have the hydrographs. Due to actual flood, not a precipitation from 500 years or 100 years. So I can use this hydrographs in my models and then predict the inundation map.
But if you want to just based on the scenario base and statistical base, you say that, for example, you will have this kind of precipitation.
Participation.
Okay.
This rainfall gauges.
Yeah, and then you will create the
HEC-HMS model for the area.
Yes, exactly, and you will create this graph.
We will grab these graphs from HEC-HMS.
Yes,
it's hydrographs.
Okay, hydrographs, and you put it to the HEC-RAS.
Yes.
Okay, I got it.
I think train is complete. Yeah. So let's show it. So let's zoom to the layer. Yeah, here's our layer. So my city is here.
Okay.
In this area. So now I have the train here. I close this, but I have it here. All right. Okay. So I'll go here. Here is creating the 2D fluid, making the geometry of the area.
Okay.
So when I click it here, I'll see my area. This is my area. So now I had to make my finite element mesh.
Okay.
So first of all, I had to determine where is my area.
Okay.
I'm going to zoom in. Yeah, here. And this is one of the branches. Oh no, this to be accurate. Okay. I want to make it as mine. Alright, so I think it is this is the okay, start this at this area. Alright, so let's say that I'm going to create 2D flow area.
Okay.
And I click here and it will start from this point.
Okay.
So here I'm going to click and go through up to
Not
here.
something accurate, just
but you know the points that you know the discharge. This is a point, this is a point, this is a point.
Okay.
But the water is going to flow here. You can go straight, but I'm just making because you had to like confine all the water.
Okay.
Because the water goes outside, it will not goes inside again.
Yes.
So alright, so I'm going to do it again because I messed it up. Alright. So let's do right here to the flow area, and we will start at this point. We will go, and I have a reading here at this stream. All these red lines is streams. and I have a reading here, and let's go like that. This is my downstream, and let's close it. Just double click and say it's 2D flow area, and I'm going to say okay, here's my 2D finite element mesh. You can make it fine by zooming in. Here's a point, so you will go here, edit, and remove this point. So you just click, so we will remove. We can move the points, edit, move the point, so we can move a point like that, and move the point like that.
Okay.
And let's so you can edit it as you like. And here we can edit, move points. Here, let's remove this point, not remove it, move, yeah, so let's make it here, like that.
Okay.
So after that, I'm pretty sure about my area, so what I'm going to do, double click on the area. Oh, before double clicking, we should remove this. So here's my area, and then go to 2D flow area, and oh no, edit 2D flow area, and we will generate the computational points. So I'm going to say it will be like 300 feet by 300 feet. This is the mesh size. And then generate the points. So I'll have more than 100 cell. 100,000 cells. So I'm going to say okay. It will generating the mesh.
So it's based on the finite
element, yeah. And the second thing is just make the boundary conditions. So I'm going here at the boundary condition lines, click it, zoom in. Let's just click it, okay, because we need to. Okay, pan, move it up, zoom in. You can zoom it out, you will see. And here's the first upstream we have. We will zoom in, and then after I have a pretty much control in the area, so I can draw the boundary condition. So the boundary condition start from here, going up to this point. You double click after you finish, so we'll say it's up 1. Okay, so we will have this line as the first boundary condition. The second thing is get the second boundary condition, which is here, and draw a boundary condition line from here up to here. And then we will say it's up to, okay. And the third upstream, so boundary condition from this point to this point.
And it should be in the meshes, is that right?
Dimensions?
In the meshes, I mean,
yeah,
not outside the area.
But I think for this version is if you make it outside, it could work, but I didn't try it, but I always make it inside. But sometimes it will not be accurate while I'm drawing the line. Sometimes it goes out because you don't see it works, but I tried with the new version, it doesn't work.
Okay, I got it.
Okay, let's draw the downstream. Alright, so I'll draw the boundary condition here. this point up to this point. We will call it down 1. Alright, so after finish that you will go to save the geometry data. But before that we need to, now we draw a boundary condition, but it may not like we say it, like coincide with the joints. It doesn't relate it to the joints. We need to connect it. So what we are going to do is just to click on this and edit 2D flow area and force the mesh recomputation to recompute with the new boundary conditions. So he can compute because you know finite element is working at the joints, not inside the area. So we need to force the computational of the boundary conditions at the joints.
Okay, I got it.
So we will say force the mesh recomputation so we can recompute with the boundary conditions, and then we will say okay. So now we can save the geometry. Save the geometry data. We will save it as geometry. We will say okay, and then close this. The second thing is to edit the unsteady flow data. So we need to load the hydrographs. So the first of all, we have 4 data we should load it here. The up 1, 2, 3, and the downstream. So I click on up 1. When you click it, this will pop up. So we will pick flow hydrograph, and he asks me about the hydrograph. So I got some hydrograph data here. I don't know if I have it. I have a file for that. Okay. Flood picture, flood information. Alright, so
you don't have?
Yeah, but I can't get it. So it will be here. Flood modeling. This is Lumber River at Mixton. Okay, so I'm going to download the data from October 2016, October 2nd up to October 28. Yes, and I'm going to say tables. So let's try tabs for it. Okay, here is the data. You can see it. He have a data of discharge each 15 minutes. So what I'm going to do is just copy this data and take it to Excel, or there's other way we can do that. You can just click save as, and we can save as text and then we will go to Lumberton Fuel Study, HEC-RAS. We can make a new folder for river reading. So let's make it up 1, save it, and go to the Excel. And we will open other worksheets. So we will this PC house, and we will pick here. Let's text file. Yeah, this one. We will open it. That's more easy. Okay, let's separate it. Alright, so this is the data. I'm going to delete these lines. So I think this is the discharge values. We are opening many things here.
It happens always to me.
Right. So we will load this data here. We are going to fix the start time at, we will say October 8th, or pick the time here, 2000. October 8th. We will say okay. So this is the format.
Okay.
And the time is 0, 0. And each interval is each 15 minutes.
Okay.
So this is the start time. Let's go here, see what's going on. What is the problem with that? Yeah, let's try this. I don't know. Flood is not responding.
I see, because it was a lot of data.
I don't think so.
Sometimes
It's just Excel file.
Yeah.
Closed. So let's start from blank. Here's the date. Okay, let's just start from October 8th. So because we don't need many data. Yeah, here's the start. Can't delete all of this. Alright, here's the discharge values. You can see it will go up, up to, at the maximum it goes to like 7,000 or 6 or something. So all what I need is this column, and I'll take it as Control C and go to the HEC-RAS and paste it here, Control V. Right? So what I'm going to say, we put EG slope of distributing flow along the boundary condition. We always put this value as 0.5. I'm not sure about this value, but you have to put a value for it.
Okay.
It says the slope for distributing flow along the boundary condition.
Okay.
Okay. But all the tutorials I saw, they put it this value, but I don't know if it's going to make difference or not. If you have any missing data, you are going to interpolate the missing values, and then you will say, okay, if you want to check, double click it and plot the data, you will find it like this. Okay, to save our time, we can use Upstream to as flow hydrograph with the same values, and we are going, it will be 08 October
2016.
Oh yeah, the format 2016, and the start 0 at time 0 was
15.
All right, and we will say the value is 0.05, interpolate missing values and plot it, as we had to say fix the start time, so we will get at the time that we need. All right, we will say okay. We will put this one also. We should download it, but for simplicity we are going to make it 08 October 2016 00 each 15 minutes. Here's the values of the flow, fix the start time on 05. Okay, this is the upstream. The downstream we will go to normal depths, assuming the fraction of the slope is 0.01.
Okay.
And we will say okay. Oh, before that, unsteady flow data, we will save it. Save unsteady flow data, and we are going to name it unsteady flow data, and we will say okay, and then close it. So we defined everything.
We just need to run it.
We need to run it, but before run it, we will go to the RAS mapper, and we will go to the 2D flow area, and we make a computational area here.
Okay.
So we will, before run it, compute the 2D flow area hydraulics tables. But we do this step before computational.
Okay.
Before doing our computational work. So we will go to run an unsteady flow analysis.
Okay.
Here we are going to say compute, but after defining our parameters. So we will say we need to do geometry processor, unsteady flow simulation. We don't dealing with sediment. We need poster processor, we need the flow, we need the depths, we need floodplain mapping.
Yes.
So the start date, we need him to start at the day,
The same.
08 October 2016 at starting time 0.
Oh.
0. Oh, yeah. We can make it 0. And the ending time is the ending of this, which is, we can end at any time here, like 20 October 22 October 2016 zeros, and then we will define the computational interval. You have data each 15 minutes, right?
Okay.
You can compute each 1 minute or each 1 hour, but when you make it 1 minute, it will do a lot of intervals. So let's make it each 1 hour, so it can do it so fast.
Okay.
But to be accurate, make it like 15 minutes. I did it 1 minute before, but it crashed. So it's 1 hour. Everything is okay. Don't say compute, just file. We will save plan, and we will say it's a plan A. Plan A, and we will say okay. He will ask about the short ID of the plan. We will say 1. Okay. So before compute, I save the plan, close it. We will go to the here to the flow area. It takes some time to compute the 2D flow area. Why didn't do it? Should we go see it? So how about going to the geometry, and we will force computational again. If there is a problem with the mesh, it will not run.
Okay.
So let's he will compute the tables with the joins and everything about the area to, do you know the input files? He's preparing the input files
Yes.
to run.
And I can ask a question here. So I want to know whether HEC-RAS consider the land cover or not.
What is the land cover?
For
you mean
example,
the houses?
Yeah, houses, and whether it is forest there or building.
Actually, it's shapefile oriented. No, it's a digital elevation map oriented.
Okay.
So everything in your digital elevation map, it should be mapped on it. So
in digital elevation map, do we have the land cover? I don't think so. We just
but
have
actually,
the
when you
elevation
of what? Of the earth?
do you mean
you
surface?
want to take the surface? You have the surface in the digital elevation map.
Yes,
because
we have it.
if you zoom in the, let's go here and here. If you zoom in here, you will find the pixels.
Yes. And because if you consider this land cover, it
will distract the flood. Or
yes, exactly.
But actually, I think it should be mapped on the digital elevation map here.
Okay.
So because each point here have its elevation value.
Yes.
You can see here in this area. Each point here have its elevation 123 in this area. It depends on the resolution of the digital elevation map. Because each color
represent a specific value.
Yes, here at this point.
Okay.
Is 1, 2, 3. So all this color is 1, 2, 3.
Okay.
This is 121. And this is 121.
Okay.
And when you will go lower, it's 190.
Okay.
So yeah.
And then and does it consider the surface roughness and Manning's ratio?
Actually, I don't know, because this parameters you control it in the digital elevation map.
Okay.
I think
so you think that
because when I was working on HEC-RAS, he is asking about the Manning's coefficients and stuff like this.
Okay. So and on that software you didn't use the land cover or the DEM?
No, just the digital elevation.
Okay.
So the water run according to its elevation.
Okay.
It goes from the higher to the lower. So now we are ready, because he said computing to the flow area, and then finally we will say
compute the
run and unsteady flow.
The second.
Yeah, here. And we will say compute. I hope it doesn't say there's error. Yeah, it will run now.
Okay.
So we will wait until it finishes the analysis, and then we will get.
Do you know how long it might take?
It depends on the time interval that you choose from the verse. We choose 1 hour, so it will not take time. Yeah.
Okay.
Can you see here? If we define it as 15 minutes, I had to leave my PC, do it, and come back in the next day. Yeah.
So this is
and it depends on the mesh size also, because we define it as 300 feet.
So this
in my model is 100 feet.
Okay.
So yes.
Okay. And I think the basic behind it is kind of completely the same as HEC-RAS, but with some minor differences.
HEC-RAS do finite element?
I think it do.
I think HEC-RAS do something like what I'm going to show you right now, because I found it on a website. It's flood modeling here. Hurricane SU imagery. Oh no, not imagery. It will be FRIS. In this website, you just say, I have the gauge on Lumber River, say it's 22 feet, and he will draw the floodplain.
Oh,
Yeah, I'm going to show you, right? Where's this website? It's on the internet. Oh, sorry about that. Why does this doesn't work?
maybe this is new. So let's plan for tomorrow. What time works for you?
Actually, you said that you will be in the.
I will be in lab all day, and even I can come campus after doctor appointment at 3-4.
So you will
Does
be
it-
here after 4, right?
After 4. Does it better
Yes.
for you?
That's the time that I'm
Okay,
working at.
that's great. So I will be here at around 4, so I can come to my office and your office,
Okay.
and we can work on the houses to fix the problem. And I need to give you more information about the concept behind level 2. At least you if you don't want to use it from the
Yeah,
houses, at least you can start coding that, because this is really easy and this is a simple formulation.
So you're coding on the ArcMap using Python or MATLAB?
MATLAB, first MATLAB, because
So you're grabbing the shapefiles from. You are going to grab the shapefiles from HEC and.
not
or-
so for the level 1 I grab it from HEC, but for level 2 I grab it. I had the something the same as you. I have the point by point building values and characteristics, and I calculated it. I wrote a code for that to calculate the losses. But what I used is just the policy of HEC, concept of HEC, to calculating the loss estimation, and then also I calculated. Also, I used the formulation for losses, because this is really easy. You just need to multiply the percentage of damage times the replacement cost. So you need to have the replacement cost, and also based on the value of the building and the characteristic of the building, you will get the percentage of damage. And this is the code. I will
I get the
explain.
percentage of damage from the flood characteristics and the building characteristics.
Yes, exactly. So let's say that you have a depth on a specific building. You have a depth of flooding, and then based on these depths of the flooding, you will go to the depth damage function.
Yes.
You will get the percentage
Actually,
of damage.
it's easy. Yeah.
Yeah, it's really easy.
Yes, if we have the flood and we have the building levels,
Yes.
and we will put them together,
Yes.
we get the flood height using
Yeah.
damage function, we get the percentage damage multiplied by the replacement value, we get the damage cost.
Yes, exactly.
Yeah.
If you
Okay.
want to use it,
Yeah, I think it will be helpful to use it. Okay, so I don't think this is. Okay, I can show it to you also. Here is that. don't know why it was opening before.
Yeah, maybe.
There is a map here.
Yeah. Maybe because of the internet network is the problem. Sometimes it happens.
And I got a very useful website. It's just say the flood height is that, and you will make a flood plane and showing you the most damaged building in red and the others in blue.
Yeah.
And also calculate the cost. It's the state of North Carolina develops this website.
Okay.
But I don't think it's accurate because the flood plain, it doesn't look the same like what happened in the reality.
Okay. They maybe use a specific algorithm or something like that, which is not really accurate.
Okay, let's see what it's about to get finished. Alright, so just going to
And this is for coastal flooding or river flooding? Or
river flooding.
Okay.
So the river is, there's a gauges on the river. You just say that the gauge will reach the level of 50 feet or 20 feet. He will calculate the damage. This is not the website, but this website say that showing you 100-year flood of the area. Here. This is the floodplain map.
Okay. This is based on the FEMA flood map?
Yeah.
Okay.
Actually, this is the FEMA flood map. You will just click on any point here, and you will get the base flood elevation is 123 feet. This is the 100-year flood. You can download the maps, and I think the maximum flood I got is 123 or 124 feet. Showing you. Because this is not the website. Oh yeah, this one.
This is your first year here?
Yeah.
Do you plan to
What?
to finish?
No. When I plan to finish, I'm just a start.
Yeah. That's right, that's a stupid question. I'm in the third year and I don't have any plans. So.
Really?
Yeah.
But I think it just will take 4 years.
Yeah. So actually for me because I didn't start with a specific project. Yes. I switch between 2-3 main projects. So
it's because always the professors need the PhD students,
yes.
But they don't know what he's going to do with this PhD
yes,
student.
Exactly. That's
so
the reason.
He have like a body, and he want to use this body to do something.
Yes.
So he will ask you what is your plans, and you come to a new project and you don't know about. Yes. That's what my professor did. So what is your plans? So I don't know anything. My master's thesis was an earthquake, and it was on a structural level, and it was on element level, not a structural levels, because it was in shear walls. Okay. So I transferred from element level to community level, and from an earthquake to other load.
Yeah, exactly.
So you had to read more, and if I read, I will not find my way because I need some guidance.
Yes, exactly. This is a problem that I had with my past because I changed the subject. I didn't change. Dr. Mahmoud changed the subject 3 times, and every time it takes about 6 months or even 1 year to say that okay, this is not working. Let's change to another
Actually,
subject.
It depends on how lucky are you.
Yes, exactly. Yes. I believe in that.
To get on the best from the first.
Yes.
Maybe you, in the first, like, I think Imad is the same. he's doing some lab works,
Yeah. Yeah.
and finally he get his way with hospitals.
Yeah. Yeah. We are doing a lot.
Yeah, but if someone find his way from the first year, so maybe finish in 3 or 3.
Yes, that's right. That's right. Because I think this is not hard. If
So,
you just focus on one thing for 1 year, it will be done for sure.
Yeah. Do you think so?
What's that?
Do you think so? 1 year?
Yeah, yeah.
So what about the other projects that you didn't get any like papers?
Yes. I submitted one paper, and for this one, we will submit another one in 1 month.
In Flood?
No, not flood. In the lab work.
Lab.
But in the flood, I'm in the beginning of that, so
Yeah.
I plan to publish it as soon as possible. It's my goal.
Yeah. So here's you are going to make a scenario.
Okay.
So we will say that the flood height now is 12.5 feet.
Mm-hmm.
So if you are going to increase it, so there is no damage here.
Okay.
But let's make it at 15.5 feet.
That's
So
interesting.
there's not damage. So let's make it here. So here we have 94 buildings get damaged. This is only for the state of North Carolina.
Oh,
This is the
that's-
only state that made this.
Oh, really?
But actually it is not accurate because, and he said that in the verse, because you can see he just, depending on this gauge,
Okay.
just raise the water at this gauge and see what's going on there. But the water doesn't come from here. The water is coming from outside the city.
Yeah.
And we have some building get damaged in this way.
Okay.
So the damage is calculated according to this area.
Okay.
And he will show you shape files of the building here and how much damage they will get. This is more damaged, more than that. If we increase the flood to the maximum point, you will see we have a lot of damage here. And if you click at the building damage, you will get tables from 0 to 1 feet, how many buildings get this levels, and what is the building that have more than 5 feet.
Okay.
So you can have it like that. We have commercial building with 5.5 feet, and this is the losses. Stuff like this. I don't know if it is working in the same way, but you say it's block level, not
Yeah, not
building level.
No.
Yeah. So let's back to HEC-RAS. He finished. Let's go to the RAS mapper.
Mm-hmm.
We will close this and open it. And we should have results here. Yeah, here it is. We will say we need the depths.
Okay.
So here's the depths what we will get. So the mesh is very rough.
Yeah.
Here's the water
Okay.
that goes through.
Mm-hmm.
My area is here. This is North Carolina.
Uh-huh.
Because the mesh is very rough, so you can see it goes very wide from the
Okay.
ground. Yeah. But if I make it smooth as mine, it will be better than that.
Okay.
So you can see the water
Okay.
working
That's great.
like that.
That's
So
interesting.
we can see the velocity.
Mm-hmm. That's one of the feature that HEC-RAS don't do that, because
Yeah.
HEC-RAS is just giving the
Uh,
depths, not
just
the
depths, yeah.
velocity.
And also, I think it doesn't give it with time.
Yeah, no.
It just give
no.
the floodplain map
Yeah.
like this, the maximum,
Yes.
something like that.
Yes, exactly.
Yeah,
Exactly.
and that's all.
Okay, and
And there's a YouTube video, I can send it to you. It's do all the steps that I'm doing.
okay.
Yes,
Thank you
will
so
be
much.
helpful. Okay.
Thank you. You helped me a
welcome.
lot. You saved me. I will help you.